Okay, so this is where you got lost. You understand how to get the row, but that's it.
Yeah.
Okay, so next you write, this is the first part, this is the second part, including the sign. So each one of these is going to get one of those.
Okay.
Do you understand what I mean by that?
Yeah, kind of.
So you're going to write a 2A here and a negative B here. Or a negative B here. A 2A here, a negative B. 2A, negative B, 2A, negative B, 2A, negative B. Do you understand that now?
Yeah.
Okay, so each one of those things gets one of these guys. Now the way that I attack it next is I would personally deal with the 2A's, and you always start with the 5th power first, or whatever power this is. If it was 6, if it was 4, that would be the number that would go here. So I'm going to start with 5. And then you walk it down. So what would be the next one? What's this 2A going to get?
4.
What's this next 2A going to get?
3.
The next one?
2.
1, 0.
1 and 0.
Now you basically do the opposite with the other term. So that negative B is going to get a 0. This one's going to get a 1, then a 2, then a 3, then a 4, then a 5. And again, I know I did this right because what do all of these exponents add to? What number?
5.
Which is what it should add to.
Okay.
Does that make sense so far?
Yeah.
Now the rest of it is simple.
Okay. Okay.
What I mean by that is, let's deal with this. You understand that says 1 times 2A to the 5th times negative B to the 0. That's what this term says right here.
Yeah.
This is the first, this is the second, this is third, this is fourth, this is fifth, this is the 6th term there. Each one of these things is its own term. Are you with me on that, Kelly?
Yeah.
Okay. Let's deal with this. 1 is just 1, right?
Yep.
Okay, let's move on to this. What does it mean to have 2A to the 5th?
You have 5 of those.
And so that would be 2 times 2 times 2 times 2 times 2 times 2, right?
Yeah.
Well, that's 32. When you take 2 and times it by itself 5 times, it's 32. And then what else?
And then A to the 5th.
So this is a 1. This is really 32A to the 5th. That's what this is. And then what is negative B to the 0 power? What is any number? I don't care what it is. What is anything to the 0?
1.
So what is 1 times 32A to the 5th times 1?
32A to the 5th.
So the first term of this equation or expression is 32A to the 5th.
And we would just do that with all of the terms.
Yep, I'm going to do a couple more with you because they do get a little tricky in here. So let's do the next one. 5 times 2A to the 4th times negative B. 5 is just 5, so we'll leave it alone. What does it mean to have 2A to the 4th?
2 to the 4th power and A to the 4th power.
And 2 to the 4th is 16.
And
A
then
to the 4th. And this is B to the 1st power. What's negative B to the 1st power?
itself.
So it's negative B, correct?
Yeah.
So I need you to think of this as really 5 times 16. This is really a negative 1 times B. Do you follow me?
Yeah.
So really I can do that times negative 1. And then A to the 4th, B to the 1st. And when I multiply 5 times 16, it's 80. And then 80 times -1 is a negative 80, a to the 4th, b to the 1st. So my next term is a negative 80, a to the 4th, b to the 1st.
All right.
Wait, I have a question on that.
Yep.
When do you get rid of the b? Because in the first term, there's no b.
What is b to the 0?
Was it 1?
Anything to the, so now here's what I mean. I don't mean, I think this is what some of you think. If I say b to the 0 and I say it's 1, I don't mean 1b. That's not what I mean. When I say b to the 0, I'm saying it equals the number 1.
Oh, so you just get rid of the b entirely if it's to the 0 power?
No, anything to the 0 power is 1.
So it's just 1. That would be every
Yes.
time.
Just, yeah.
Okay.
What's 10 to the 0?
That would be 1.
What's a million to the 0?
1.
What's negative 5,762 to the 0?
1.
So it doesn't matter what b is. If it's to the 0 power, it's going to automatically kick to a 1.
Okay.
So there's no b because it's gone. Do you see how this is b to the 1st power?
Yeah.
That's not 0, so there is still a b there.
Okay.
Good question. Does it make sense now?
Yeah, I get it now.
All right, I'm going to do one more, and then we're going to talk about something here. This
All
is
right.
10, 2a to the 3rd, negative b to the 2nd. Okay. This is just 10. What does this 2a to the 3rd turn to?
An 8.
8.
And then an 8 to the 3rd.
Yep, because 2 times 2 is 4, times 2 is 8, because I'm doing 2 times itself 3 times. Yes?
Yep.
What happens when you have a negative b and you square it?
It becomes positive.
And so it's b squared. So remember how this right here was a positive term? This was a negative term. This term right here is going to be positive because I have a 10, a positive 8, and a positive. Do you get what I mean by that?
Yeah.
So this is going to be 8 times 10, which is 80. And then a cubed b squared.
Okay, that makes sense.
Okay, so let's just talk about this. Because I have b to the 3rd power, what is this next term going to be?
Negative.
Yep. Because all this other stuff is positive, but this is going to remain negative. Because anytime you have to the 3rd power, it doesn't kick it back to positive. So this next term is going to be negative. You with me?
Yeah.
What's going to happen when I raise b to the 4th power?
It'll be positive.
And then what happens when I raise b to the 5th power?
It'll be negative.
Does that make sense?
Yeah, that makes a lot of sense. Thank you for clearing it up.
Just take it step by step, nice and easy. Notice I attack each term bite-sized pieces. Hopefully the setup is now making sense on how you set it up. And then everything else is just honestly, power to a power, like have x to the 2nd plus y to the 3rd was one of the questions, and you're supposed to raise that to the 5th. Again, since I'm using the 5th, everyone should understand the numbers I'm choosing here. I'm not doing this fully problem out. I still start with my x, dot, dot, dot. I'm not finishing it. I do x to the 2nd and then a y to the 3rd. Then here I do an x to the 2nd. Here I do a y to the 3rd, and so on. This goes to the 5th power. This goes to the 0. This one would go to the 4th. This one would go to the 1st. What happens when I have power to a power? You multiply them. So this would all, then this turns to 1. So I'd have x to the 10th. Here it would be plus 5. X to the 8th. Multiply y to the 3rd, and so on. So it's really a lot of the same stuff that you've done in the past when you're simplifying them. Kind of makes sense?
Yeah.
Questions on homework? Okay, so here's my, Kelly, my suggestion to you. And again, I'm not going to pretend like I don't know what's going on, and I am not afraid to talk about real life stuff. So, Kelly, I would encourage you to, if you maybe tried all the odds last night, I did not assign you any of the evens. I would go through and I would probably try one of the hardest questions on there, maybe like 64. Or 60, I'm sorry, 62. And I would try just one problem from the even sections tonight, because now you said you made it clear to you. And so you should understand it. And I would not be afraid of using PhotoMath or Wolf Alpha or any of those Mathway, all those apps that you guys I know are using. Now, the way you use them for positive is you should be doing your or whatever website, if you're talking to someone, the way you use them positive is you do those questions, you get the answers, you can check them using those apps. But by the way, sometimes those apps do give you the wrong answer, just so you know, because they're doing more advanced math than we are doing. So that's why when sometimes you use them on the test, they're not giving you the right answer. The idea is to use them as a tool, not as something that you're going to do, because you know what, you might get your grade in my class and you might cheat your way through it. But if you are trying to go on to college, if you are trying to take an SAT or a PERT, they will not allow you to use those things, and it's going to catch up to you. If you end up just going to SPC, you're going to take a PERT. You're not going to be able to get the score you need to score on to get into the college level classes, and you're going to have to pay to take high school classes over, because they don't let you just come into a math classroom in college and not know the previous. So you might have to take like 2 or 3 classes of remedial high school level classes, and the reason that sucks is you have to pay for them, and they're semester long classes, which means you would be in a year and a half of college and not have taken your college level math class that you need. So you'd be out money and you would be out time. So I'm encouraging you to use this for the right way, because Algebra 2 is definitely on the SATs. If you can't get past into Algebra 2, the PERT, you will be taking remedial math classes, because college algebra is basically the same thing as Algebra 2, and it's like one of the first math classes you take. So if you can't get into this level of class on that PERT, which is not a 98, I know some of you have taken it. That was the old score in order to get the high school Algebra 1 credit. To get into college algebra, you have to score 128. So those scores are very far away from each other. So just make sure that while you're taking this class, you're doing, being authentic for yourself and trying to learn it. Because like I said, you're not going to hurt me or anyone else, mom or dad. It will come back to bite you in the butt. It will be known when you move on and go into college. So I hope that makes sense. And with that, we're going to move on. Since no one has questions, we're going to move on to today's lesson, which is 3-4. We're starting it. We're going to talk about this thing called long division. So back in the day, you were taught to do something like this. And hopefully, I'm going to try to help you remember your place values. Hopefully you remember, one thing you did is how many times does 5 go into 1, and you should say 0, and you actually do not have to write the 0 here. We're going to talk about that because that's not a placeholder 0. Zeros between numbers and the decimal place. These zeros, numbers, and the decimal place, these zeros. These zeros right here, that looks like a really weird smiley face. These numbers right here are called placeholder zeros. They matter. These zeros right here and these zeros right here are not placeholder zeros and do not matter. Because if I take them out, this is still 700. If I take these out, it's now just a 7, which changed the value. So these are important, they matter. These are not important. This 0 right here is going to be in front of numbers, so it is not a placeholder value 0. That's why it does not matter. Later on, we might have another 0 that pops up, which is between the number and the decimal place, and that's called a placeholder 0, and it will matter. So please know which ones are important and which ones are not, so I don't have to put anything up there. And then I go, okay, how many times is 5 go into 17? Should go into it 3 times. 5 times 3 is 15. Some people make those zeros right there, which is fine. And then you do the subtraction. 4, 5, 6, 7 minus 5 is 2. And then this cancels out. How I know I did this right is this number right here should always be smaller than this number right here, which it is, right? Because if this number was bigger, then that means I could have made this number bigger here. So since it's not, I know I did it right. How many times does 5 go into 26? 5 goes into 26 5 times. Notice I'm doing the 5 times the 5, and that's what I write down here, which is 25. And when I subtract, drop the 4, drop the 5, drop the 1. This cancels out. Again, I know I did it right because 5 is bigger than 1. How many times does 5 go into 15? 3 times. It actually goes into it with a 5 and a 1 and a 5. When I subtract, I get the 4. This is gone. How many times does 5 go into 4? Well, it can't. So what do I have to put here? You have to put the 0 here. This one is a placeholder 0 and matters. This is called my remainder. And when you were in elementary school, you know, like first learning this, you might have, if your teacher said, just put our R4, which stood for remainder 4. Then you got into like 5th and 6th grade, and they probably hopefully told you to put the remainder on the top and what you were dividing by on the bottom. So my answer would be 3,530 and 4/5. And let's not remember or forget what that means. That means if you take 3,530 and you times it by 5, what answer will you get? Kelly, do you know what number you'll get?
Wait, sorry, you cut out. Could you repeat the question?
If you multiplied 3,530 4/5 times 5, what number will you get?
The number we started with, 17,654.
Yes, you will. That's what division is, remember? Don't forget that. This goes into this many times. That means that this times this is what this equals. What happens when something goes into something perfectly? Like if I said, hey, how many times does 5 go into 10? And you put a 2 here, and there's, when you do this, there's a 0 remainder. What does that mean for the 5 and actually for the 2? What are those called? They have special names. When something goes into something else, we call it a factor. So 5 is a factor of 10. 2 is a factor of 10 because they both go into it with a remainder of 0. The reason I'm bringing that to your attention is, do we have something called factored form? We do, and that's all going to come back here very soon.
Are we not allowed to, like, when you put the 4/5 fraction, are we able to also just put 0.8?
I don't want you doing that because I'm prepping you for what we're going to do today, right? Because that's an old skill. But what I'm doing today, you will not be able to do that because we're not going to be dealing with numbers you can make decimals. Okay. So I need you to know that you can make it that fraction, because everything that I just taught you, I'm going to do exactly today, just with nastier numbers.
Okay, that makes sense. Thank you.
Aha. So here we go. Now what I'm going to ask you to do is I'm going to ask you to take x to the third plus 5x squared plus 6x plus 9, and I'm going to ask you to divide that by x plus 3. So first off, let's set this up. If I have it like that, remember that means the x plus 3 goes on the outside. The x cubed plus 5x squared plus 6x plus 9 goes on the outside, or on the inside. And then one thing we need to talk about with long division is you have to make sure, and this is not going to come up in this problem, but it comes up in the next one, that this goes from power of 3 all the way to power of 0 and does not skip any. So you see how it goes 3, 2, 1, and then to nothing? That is good. It must do that because these are going to be what I call the place value holders, and sometimes we're going to have to write them above there, and they weren't in my original equation. You'll see that in the next one. So if it skips one, we have to put a 0 x whatever squared or x just 0x. Just make sure it walks from 3 to, this is to the first, and then technically this is x to the 0. So since it does, I'm good. I don't have to fix anything. All my placeholders are there. Does everybody understand that so far?
Yeah, I understand that part, but I don't think I know how to do that long division stuff.
No, what do you mean? The old way that I just did?
Yeah, I didn't learn that way.
Okay, well, make sure you watch this because that's a key.
Yeah, I'm paying attention in this one.
So here's what we do. I need to make x become x cubed. We always make the first part of this one become the first part of that one. So I go, what in my head I'm thinking x times what equals x cubed. So I'm taking the first one and I'm making it become that. And what is the missing piece? X times what?
X squared.
So x squared is what I'm going to need in order to make that. Where is that going to, what place value does that belong in? Does that belong in place 1, 2, 3, or 4?
Would it be 2 since it's squared?
Right, so that's where I'm going to write the x squared is right above that. Does everybody understand why I wrote it there? It's right above the place value that it goes with.
Yeah.
Now, what I do with this is I actually have to take this and then multiply it by this and that. What is x squared times x?
X cubed.
Notice where I put that in the place value that it belonged to. What is x squared times 3?
3x squared.
Notice I put it under the place value it belonged to. And then last time, what did we do with our long division? What did we do with those numbers? We subtracted them, yes?
Yeah.
Now, I'm teaching you something because I'm showing you why you hopefully will make less mistakes. What if I had this problem here? This is what I really have. What if I had that problem? That's what I have above there. What would you guys do with this negative to make it easier?
Distribute it.
So, do you see this subtraction sign up here? Right here? Whoa. Do you see this subtraction sign?
Yeah.
I personally distribute it. Meaning, what does that make the x to the third power? A negative. what does that make the 3x squared? A negative. Instead of subtracting them, I change both of their signs. Why? Because it gets trickier later on. I will bring it to your attention. But if you just leave this as a plus and this as a plus and you subtract, you need to subtract these two, which they cancel out. But then you have to go 5x squared, and then remember that you are minusing 3x squared. What do you think some kids do when they see a 5x squared and a 3x squared? What number do you think when they do it wrong they put here?
2.
No, that would be right. What do you think sometimes they forget that they're doing because it's way over here? What do you think they forget they're doing?
They probably forget they're subtracting.
And what do they put down here?
A 7 or an 8.
Because that's a 3, right?
Yeah.
Do you see why they would make that mistake?
Yeah.
So what I do, how did I tell you I combat that?
Distributing the subtraction sign
And so
before
this
you
becomes-
do it.
Yes, before I do it. So then I go, hey, a 3x, x to the third and x to the third, these guys cancel out. A positive 5x squared and a negative 3x squared make a 2x squared. And then you drop the rest of it down. Does that make sense for the first part? I'm not finished with this problem, but does that make sense for the first part?
Yeah.
We are
That
going
makes
to,
sense.
we're going to do that same thing over and over again. I am now going to try to make, this is my new thing I'm dealing with. I'm going to try to make the x become a 2x squared. So in my head, I'm thinking, how do I make x times what becomes a 2x squared? So what is missing here?
A 2x.
And so notice I'm going to put that above the x spot, that same kind of place value. Does that make sense so far?
Yeah.
Now, what am I going to do with the 2x? Jonah, what do you think I'm going to do with that 2x? Noah, what do you think I'm going to do with the 2x?
Which
You guys-
Noah?
Yeah, you Noah Brown. Sorry, bud.
All right.
What do you think I'm going to
2x.
multiply that in 2x by? You there?
You talking about the 2x squared?
No.
Yeah. Are you talking 2x on the top or the 2x?
The 2x on the top. What am I going to multiply this by? Okay, well, what did I multiply the x squared by, Noah?
If I'm gonna be completely honest, I wasn't even paying attention just now.
Okay, so let's do this because I'm telling you right now, it's going to be confusing if you don't. Callie, can you help him out?
We distribute it.
We're going to multiply this 2x by the x and by the 3. What happens when I multiply the 2x by the x? I get 2x squared. What happens when I multiply the 2x by a 3? I get a 6x. But remember, I'm supposed to be subtracting them. But instead of subtracting, Mr. Martin said, make this a negative. Just change the signs of these guys. It will, I promise, make it much easier later on, especially in our next example you're going to see. These cancel out. That's good. These actually end up canceling out too. That doesn't always happen. And then I'm left with just a 9. Can I make x become a 9? Can I say x times something gets me to a 9? No, you can't. So that means that 9 is my remainder. Janina, I think you were the one who asked me this. This is why you can't do what you tried to do last time, because you can't just throw zeros or a decimal place. Where does the remainder go? The remainder goes on top. What you were dividing by goes on the bottom. So your final answer would be x squared plus 2x plus 9x over 3. Is this a factor of this? It's a very quick and should be easy answer.
No.
Yes.
I got a no and I got a yes.
Yes. Yes.
What does it mean to be a factor?
It goes in perfectly.
It goes into it perfectly with no what, guys?
Remainder, so it's not a factor.
What is this? This is a remainder, which means this is not a factor of that. Now remember, every number can go into any number. But if it goes into it with no remainder, that's when we call it a factor. That's a special number. Next example. So I start this off and I go, this is going on the outside. 2x plus 3 goes into, now why do I have a problem with this one? Why do I have a problem with this? I told you that at the beginning of the last one.
Because the
Doesn't go
8 isn't
3, 2,
simplified.
1.
Kelly, what'd you say?
I don't really know, but the 8, maybe?
Nope. Nope.
It's because it
Not like a
skips.
sequence.
Who said that? Daniel?
Yeah, it skips.
Yeah, what did I say about the exponents? It has to go 8x cubed. Then it has to go to x squared. Are there any x squareds up here? No, they're not. So guess what I do? 0x squares. Are there any x's up here? No, they're not. So guess what? 0 x's. You have to fill in those place values. It will make your life much easier. If you are having a hard time on tonight's homework, it's probably because you're making an error there, especially if it's just starting off that you have a hard time with. Make sure it goes from 3 to 1 and then plus the 27 goes back there. Got to make sure it walks it down. Now the game that we play is, how do I make 2x become an 8x? Well, it needs 4x squared, so that would go above this right here. And then what we said is we have to multiply this times both of these things and just see what happens. When I multiply this times this, it better cancel this first one out. When I multiply this times this, whatever happens, happens. I can't control that one. So we said it was 4x squared. 4x squared times 2x is 8x cubed. 4x squared times 3 is a 12x. Now here's what I'm talking about. If I subtract, I am telling you I've seen this over the years. Kids do a good job of remembering the subtraction for the first one, but when they go here, they see a positive 0x squared, they see a positive 12, and they write a positive 12x squared, which is wrong. Because this should be read as 0x squared minus 12x squared. So this should be a negative. So the way I told you to help fight that error is before I do my combining, change these signs, and then see you have a 0x squared, you have a negative 12x squared, and so you have that. That's one of the reasons I was trying to show you that, is because I've seen a lot of errors on that. Now my thing is, how do I make 2x become the negative 12x? Well, I need a negative. 2 times 6 would be 12. X times x would be x squared. Distribute this thing. I got to multiply this by both of these things. Remember, this times this, better cancel this first one out. This times this, whatever happens, happens. So negative 6 times a positive 2x is a negative 12x squared. Perfect. Negative 6 times a positive 3 is a negative 18x. But I need to remember that I'm subtracting. And so what I do is I distribute the subtraction, which changes both of these signs. And then I'm able to see a positive and negative 12x squared cancel each other out like it should happen. And then this turns into a 18x plus 27. How do I make 2x become 18x? All I'm missing is a 9. So I put plus 9 back here and then distribute it. And this times this gets me to 18x. And this times this gets me to a positive 27. But remember, I'm subtracting them. So really, this is a negative 18x and a negative 27, which is cool because not only does this cancel out, this cancels out with leaving me with a remainder 0. What does that make? The 2x plus 3 as I compare it to this whole equation right here. 2x plus 3 is a what?
A factor.
It is a factor of this, which means if I take 2x plus 3 and I times it by 4x squared minus 6x plus 9, right? This times this. If I distributed this and I combined like terms, it would turn into this. Do you remember we were taking x squared plus 5x plus 6 and I was saying, hey, this is standard form. I need you to change it to factored form. That means if you took this and divided it by this, you would get this answer, right? These two things are factored. This times this is that. Well, this is factored form, or this is standard form, and I taught you how to change it to factored form. What I'm showing you today is sometimes when you do this division, you end up with a 0, which means this right here has this as a factor. So there's some way that I can change the 8x to the third plus 27. That is actually 2x plus 3 and 4x squared minus 6x plus 9. This is standard form, and this might be factored form. I'm not sure yet. I'm not completely teaching you this because I might still be able to factor this. That's what we're going to get to later on in chapter 3. How to take this and change it into completely factored form. And this is just the start of it. This is one way to get it done by long division. We can test to see, is this a factor of it? If it gives me a remainder of 0, yes, it is. This is called long division. Does that make sense so far for tonight's homework? All you're going to practice tonight for homework is the long division.
Yeah.
Yeah.
Makes sense.
Remember, division and multiplication are opposites of each other. So if 5 times 2 is 10, then 10 divided by 2 is 5, right? They're called a fact family. That same thing happens with these polynomials. Same rules still apply. All right. Other than that, you'll see homework up on Portal. Make sure you try it, and I will see you tomorrow in class.
Have a good day.
Thank you too.
Bye.